Let's talk a little bit longer about two I terms that are very important in database design. That is integrity and indexing. Types of data integrity that you may have in your database are domain integrity. That just means that the field contains the data you expect it to field, and we can make sure that we do that using our check constraints. Then there is entity integrity. This just means that you can't have a duplicate record. We don't want duplicates in a database, and each record should be unique. Obviously, if you have a primary key, each record will be unique. That's the definition of primary key, and that is why your primary key cannot be null. Finally, we have referential integrity, and that says that the foreign key must be consistent with the primary key. You can't have a foreign key value if the primary key value doesn't exist. We want referential integrity. Let's take a look at what would happen if you don't use referential integrity. Here is the relationship window in the Guitar Shop database. I want you to look at the products is related to categories through the category ID. Notice the other relationship says one-to-many, but this one doesn't. If I right-click on this and go to Edit Relationships, you notice I've taken the Enforce Referential Integrity check out. So it is not going to enforce referential integrity. Let's look at categories. So the categories are types of products that can be purchased at a music store. The category ID is 1 to 4. It relates to products here. So when I add a new product, I should add 1 to 4. But because I don't have referential integrity, suppose I look at this and I think, oh, 11 for some reason. And I'm just going to make some data up here. And that looks good. And because I don't have referential integrity, it's allowing a category of 11 that doesn't exist. A relationship window, so I can edit the relationship. Normally, this is what you want checked. And it says it can't do it because it violates referential integrity. This is what I tell people when they're designing databases. You probably want to set your referential integrity before you enter any data. Because if you try to do it after data is entered, you might have a hard time finding what records you need to delete. I happen to know what record I need to delete. And let's try this again. I'm going to enforce referential integrity, come over to products, and try to enter 11 again. Just miscellaneous data. And notice what happens. When I try to save the record, it says you cannot change the record because a related record is required in categories. There is no 11 in categories. It will not allow me to create this record. I'll just hit escape here and the record is gone. By using referential integrity, you can eliminate some anomalies. But what happens if you need to change the primary key? What if someone's phone number is the primary key and that customer gets a new phone? What should happen to the related records? The rules for maintaining referential integrity is you can't delete a record from a primary table if there is a matching records in a related table. Let's try this. Referential integrity is set again, and I have category IDs of 1s, 2s, and 3s. If I open categories, I have a 1, 2, 3, and 4. Should I be able to delete 4? I believe so, because there were no 4s here in product. Get the warning, but it allows me to delete it. Should I be able to delete 1s? No, I can't delete 1s. Referential integrity will not allow me to delete the 1s, which is what we wanted to do. Rule 2. You can't change a primary key value in the primary table if there is a related record. Here's our products table. Categories is 1, 2, 3. Someone tells me to change all the category IDs that are 1 to 11. Can't do it. because there is not an 11. The third item, you can't enter a value in a foreign key field if the related table doesn't exist in the primary key of the primary table. And we've already done that. That was our first example. Number 4, you can enter a null value in a foreign key specifying that the records are unrelated. And this is true. You can enter a null value as long as there's an optionality when you did the ER diagram between the two entities. Was there an optionality? Then you should have designed the table so that nulls are allowed. Enter that null instead of that not null. Let's test. Here is the SQL that created the products table. And notice the foreign key category ID is set to null. In that case, I will be able to leave the category ID blank when I add a new record. I'm going to add a new record, leaving category ID blank. And let's see what happens. It worked fine. I'm allowed to leave it null. So the question is, how do you as the database designer make sure that these rules get enforced? These are the relationships created through the script that you ran. And notice that just creating the relationship in SQL when you're doing the create table automatically enforces referential integrity. So there's not a next step. The next step is in Access, if you didn't want to do that, would be to take that out, but it's automatically there. We've already discussed the possibility that a primary key may have related records, but you need to edit it, such as a phone number. If a phone number were used as a primary key, you may delete that record. What should happen to the related records? Should they be deleted? You may edit that record. Should the related records be edited? Here are 4 options that you can take. By default, we're doing no action. This is everything we've already done. All the demos I just did were the no actions. But you could cascade. That means I'm going to delete primary key record, go and find all the foreign key records, delete them. I'm going to update the phone number, go find the related records over there in the foreign table, and update those phone numbers. Those are cascade. You can cascade update, cascade delete, or do both. Another option is when you delete, maybe you want to keep the existing foreign key records, but you're going to set them to null because in order to force referential integrity, if you've deleted the primary key, you can't keep that value in there. Another option is to set some default value. So here's some SQL that will do that. And in this example, we've got our foreign key constraint here. Notice that you have the 2 options, and you can do one or both of these. In this case, this will cascade delete and cascade update. If a record is deleted, go find all those foreign key records and delete it. If a record is updated, go find all those foreign key records and update. I think that's a good option. Here is another example, however, and we're not going to do anything when we update. That's going to be a no action. If you update, it's not going to allow you to do that, but we're going to allow a record to be deleted. And if the record's deleted, we're going to go into the foreign key field and we're going to set that value to null. And here is another option in which if the primary key field is deleted, we're going to set the foreign key field to default, whether it's deleted or whether it's updated. Again, if you don't indicate these on deletes and on updates, the default action is no action. You can add those referential constraints in your SQL, but in Access, you can also add them in this window. If I go to edit a relationship, you'll notice that there's an option to cascade update and cascade delete. And now that will be set to cascade update and delete. That covers the I integrity. Now let's look at the I indexing. Just got one slide here. And index is implemented with a structure called a B tree or a binary tree. I have some links if you're curious, and you may study it in a future course. You do not need to know what a B tree is in this course. But I want you to know what fields you need to index. That's part of the design of your database. You should index secondary keys. These are the fields you do searches and sorts on. You don't want to have a user waiting for the data to get back when they're searching for something. You want it to be quick, and an index allows that. Imagine trying to find a keyword in your textbook, and you do it one page at a time. It might take a long time. If the author created an index for you, you go to the index and find it very quickly. Foreign key fields usually are going to be indexed, not always. By indexing the foreign key field, when you do those cascades we were just talking about, that's going to happen a lot faster. And when you do queries that join tables, that's going to happen a lot faster. However, if your table size is small, such as my categories in my database model I developed, there's only 10 records, no need to index that foreign key over in movies. So don't index when there's only a few values stored in a field, even if there are millions of related records.